Hello, everybody. My name is Florent Bocquelet. I am a machine learning manager at Unity Labs in the ML Artistry team. The ML Artistry team develops new content creation tools based on machine learning to speed up and ease the creation of artistic content. And today I'm going to show you some work we did around character animation. But before I begin, please keep in mind that nothing that I'm going to share today is an actual product. We are sharing with you research results that are not publicly available yet. Why character animation? Today, character animation is still an expert job. It is pretty much out of reach for people with no artistic experience to create good-looking animations. However, we all are capable of imagining how a character could move. So we believe that this limitation mostly comes from the tools themselves and not from the user, and that machine learning could be used to overcome this limitation. Before I dive into my demo, let me show you how posing a character is typically done. I'm not an artist or an animator myself, but I got that character ready for animation. You can see that I have a few controls on that character, and that as I move them around, the software is performing inverse kinematics so that I don't have to move each joint individually. While this is convenient and gives me precise control, you can also observe that many of the intermediate poses are not really looking good or realistic. They are sometimes even impossible for a real human. This is typically combined with complex handcrafted constraints like that foot roll, for instance. If I spend enough time on these, I will eventually manage to pose that character sitting on that chair. But for a beginner like me, this is a very time-consuming process, and it is still hard to achieve something looking good and natural. So we developed a tool to make that posing process easier for beginners. This is the same character inside our tool. The 4 orange dots that you see on the hands and on the feet are input positions to a machine learning model that predicts the full pose of a character up to individual fingers. You can see that as I move those controls around, the intermediate pose keep being balanced and natural. And this is because our model was trained on a large amount of motion capture data. One thing we really wanted to enable is to allow users to specify those constraints in any order or any number. So I can, for instance, remove a constraint on the right hand and the one on the left foot and pose that entire character from only 2 points. I can then add more constraints like that one on the knee to refine the pose and so on. We also support other types of constraints. For instance, global orientation constraints specify the orientation that the joint should have. One nice thing is that orientation and position constraints are totally independent from each other. So I can ask for a specific orientation of the hand, but let the model figure out what is the best position. We also support look-at constraints, which are a target at which the character should be looking. Let me show you something interesting with that constraint. I'm going to remove the rotation constraint on the right hand and on the chest. I'm going to pin the hips, free the left hand, pin both feet, and remove the constraint on the knee. So I only have 3 constraints, 2 on the feet, 1 on the hips, plus the look-at target. And I'm going to make the character sit on the ground, like so. You can see that as I move the look-at target around, this has a very broad impact on the overall pose to keep it looking natural. Okay, let's try to pose that character sitting on that chair again. So I have the same chair here, and I'm going to bring in a new character and move it a bit closer to the chair. Sounds good. We combine our tool with a physics solver so that it is easier to pose characters interacting with the environment or with themselves. For instance, here when crossing the legs, you can really see the physics in action. I'm going to have the character look forward move that hand closer to the knee, and that other one as well. Like so. Maybe refine a bit here. And you can see that it only took me a few manipulations to pose that character sitting on that chair. We also combine our machine learning model with standard retargeting techniques so that you can reuse the same model on a character with a totally different skeleton topology or morphology, like that complex character. So I'm going to try to pose those two characters interacting a bit together. I'm going to make that character sit next to the other one. Oops. Like so. I'm going to have them look at each other. Bring the hand in the back of the other one. Like here maybe. Good enough. Maybe try to have him grab his arm with his hand. Maybe even closer. And finally have them really look into each other. Okay. Good enough for now. If you're training data, you can also train the same kind of model on any type of character, like that dog. And you will still benefit from the same kind of controls. For instance, the look at target or positions. One of my favorite things to do is to make the dog roll on the ground, just like this. And finally, we can have it look at our two characters. And here you go. You can see that with only a few manipulations, I was able to create quite a convincing scene. But so far, this is only static. So the next natural step is to bring motion to this. And I'm going to share with you some very early results of research we have been doing on motion generation. So this is still the same character, and you can see that I have access to the same kind of controls to pose it. But now at the bottom, you have this timeline. So I'm going to add a few frames to the animation. And right now, this is only a static frame, so nothing really interesting happening. But if I go to the last frame and I slightly modify the pose, you can see that it kicked some generation process here. I'm going to ask it to generate again for the whole duration of the animation so that I get a suggestion of some idling motion for our character. And this is what we get. So it feels like that character really wants to walk. So we are going to just make him walk forward. So with a standard tool, if I wanted to have that character walk forward, I will have to pose each key moment of the walk cycle. But the nice thing about motion generation is that you can just specify the final position that the character should have and let the model generate the in-between. So for instance, here I have this slow-paced walk to the final position. If I want the character to move further, I just have to change the final position of the character and ask it to generate again. And you can now see that it's taking bigger steps to reach the final position. Maybe it's a little too far, so I'm going to move it back a little bit and regenerate again. Okay, that's good enough for now. But walking forward is not super exciting, so I'm going to try something more challenging. I'm going to have it land on the side, maybe, like so. And let's generate the full motion again. And you can see that it is still able to generate a convincing walk cycle. So I'm going to push it even further and try almost a full turn and regenerate the full motion again. Okay, that will do for now. So let's imagine that that character is turning back because someone is screaming at him and threatening him with some weapon. So the direction of the character would be to turn back, but also to raise his hands above his head. So I'm going to raise the hand, both hands actually above his head, and regenerate the motion. So let me have a quick look. Okay, good enough for now. But you can see that it's actually turning back and raising its hand a little bit both at the same time. So I'm going to go to the middle frame here and create some anticipation by having it look back first. And regenerate the whole transition. So now you can see that the character is looking back, then raising his hands. Okay, we will keep that for now and add a few more frames. We are going to imagine that this character is actually in trouble. Like he is threatened by a cop that is asking him to kneel down. So I'm going to make the character kneel down now. So I'm going to bring that one to the ground, like so. Maybe bring down the hands. They are going crazy over there. Okay, and have him put his hands on his head. Both hands. Okay, let's keep it like that. So if I play this now, it's turning back, then going on the ground. So I find the transition from hands above the head to the ground a little rough. So I'm going to actually ask to regenerate the transition again. A little better. So to finish, we are going to add a few more frames of the character, maybe bending a little more to really pose the motion at the end. Maybe moving a bit his hands. And as previously, I'm going to regenerate a bit the transition before. Okay, let's see how it looks. Again. Okay, I'm probably not going to win an Oscar for this animation, but I can tell you that for someone like me with no artistic experience, it feels quite good to be able to create that in a few seconds. And I think it shows some potential for prototyping ideas or quickly drafting some animations. So another thing we have been working on is imagine that you want to animate your character, but you don't want to start from nothing. Like you have some references that you want to use. Like for instance, you took a picture of yourself performing some action or a video of yourself performing that action. So we have been doing some research on pose estimation, which exactly does that. It poses a character from an image. So I have my character selected, and here I have a bunch of images. So for instance, I have this image of a girl kicking a bag. So with my character selected, if I open that image, then the character directly goes into that pose. And I still have access to the usual controls to refine the pose. So let me try something a bit more challenging. Oops, something right wrong way. Didn't see anything. So I'm going to add a bunch of characters, 3 of them together. Up. I'm going to select all of them. And you can see here that I have a picture of like those 3 guys celebrating some victory together. So with the 3 characters, I'm going to apply pose estimation to all of them at once. And I can still refine the pose. Like maybe this is not that like that. And you can really see how the physics comes in handy when you have multiple characters interacting together. So this is still very early research result that I'm sharing with you today, but I hope this gives you a broad idea of what we are trying to accomplish there. Thank you very much for your attention.